All right, so a combined function means that you take two other functions and combine them in some capacity. So you're either going to add, subtract, multiply, or divide two functions together. So add, subtract, multiply, or divide two functions. So essentially, if you can add, subtract, multiply, and divide, you're going to be okay, which I know that you can. I believe in you. So this is going to be just fine. So for the first one, like 1, 2, 3, 4, and 5, we're going to use these two functions, f of x and g of x. And for the first one, it says find f plus g of x. Literally, all that means you're going to do is take this function plus the other function. Like, it really is that easy. Like, that's all that it is. And then you just have to put the like terms together. So what's going to go together here? Like terms. Yeah, good. We're going to have 4x, 3x plus 1x would be 4x, and then -1 and -4, -5. Literally, that is it. You're just adding them together. Same thing for subtraction. I will say be careful with that though, because negative signs throw people off. So just be careful. We're doing f minus g of x. So you want f of x, so this first one, and you have to subtract all of g of x. So just make sure you give it a hug. You want to subtract the whole thing. And so then you're going to distribute the negative sign. So it'll be minus x plus 4, and then put your like terms together. So again, just be careful with negative signs is the only thing with that. This will be 2x squared plus what? Get plus 2x, and then -1 plus 4 will be plus 3. Now, when you do g minus f of x, that's going to be different. It's not going to come out to the same thing. If I reversed them when I was adding, it wouldn't make a difference because it doesn't make a difference what order you add in. Like g plus f would be the exact same thing, so I didn't put it on here. But this one, it's going to be backwards. You're going to have to do g of x, which is the x minus 4, minus f of x. And again, you have to subtract the whole thing, so just put some parentheses around it. And then again, make sure you distribute the negative sign because you're subtracting all of it. So it'll be minus 2x squared minus 3x plus 1. And then like terms, and I still like to make them go in descending order. So it'll be negative 2x squared. And then what? Minus 2x. And then minus 3. So what do you notice? Can you compare and contrast these for me? What do you notice happen? They're the exact same thing, but opposite. Does that make sense? Because one's f minus g and one's g minus f. So if you find this one, do you need to do the work for this one? No, just do the exact same thing except opposite. Just negate all the terms. All right. And then we have f times g of x. So that means you're going to multiply them together, which is just a lot of distributing. It's another one of those things that's like tedious, but not difficult. Okay, so we're going to distribute the x to everybody, and then we'll distribute the -4 to everybody. It's just a bunch of distributing. So this will be 2x cubed plus 3x squared minus x. I just took the x and multiplied it through there. And then we're going to distribute a -4. So just make sure you bring the negative with it. That'll be minus 8x squared minus 12x plus 4. So you get this big long string of terms. And then again, we're going to put the like terms together. So 2x cubed, and then let's see, how many x squareds are we going to have? Good, minus 5x squared. And then we'll have minus 13x plus 4. So again, it's just multiplying all of that together. And then dividing, this is your synthetic division. So we're going to do F divided by G. What number would go in the little box off to the side? 4, good. And then your countdown is in order. It would be 2, 3, -1. So bring down the 2, multiply, add until you get to the end. So 4 times 2 is 8. Add the column, you get 11. 4 times 11 is 44. Add the column, you get 43. The remainder is not necessarily going to be 0. It's just going to be whatever it is. And then we're going to put the x's back in. So this will be 2x plus 11. And then it's been a minute. Do you remember how to write the remainder? Over, good vocabulary, over the divisor, which is x minus 4. Perfect. So the next little set of problems is the exact same thing. I just gave 2 different functions. I'm going to pause the video. I just want you to try them with your group, with your people around you, and then I'll put up the answers. I just want you to make an attempt. Also, it's a way for me to not just be up here talking at you. So for a composite function, you're not adding, subtracting, multiplying, dividing. You're actually putting one function inside of the other. This is this thing. Do you guys remember this from last year, or sort of? I always say it's like F got hungry and ate G. So you're actually putting one function inside of the other. The other way you can see this written is like this, F of G of X. It looks like fog. I will not conceal from you. I find this very annoying. You will see it written that way. I feel like this, it's really easy to see. F is the outside function, G is the inside function. This looks, I don't know, it makes it more difficult to tell which is outside and which is inside. And the other thing is, it's like a little circle, but it's really easy to confuse with multiplication. Do you get what I'm saying? So be really careful. Multiplication is just a dot. Composite functions is a little circle. It almost looks like a degree symbol. I would have loved to have been in the room when they worked this one through, though. What symbol shall we use for multiplication? A dot. That won't confuse anyone. It'll be fine. Do you know what I'm saying? Like, do you remember when you're in elementary school and it's an X, but then you get to algebra and an X is a variable? So they were like, oh, we got to come up with something else. They were, a dot. They weren't very creative. Anyway, all I'm saying is just be careful, because this means composite and the dot means multiplying. Okay, so your inside function is plugged into the outside function. So you're not multiplying them together. One is actually getting plugged into the other. We're going to try it just with numbers first, and then we'll do it with variables. And don't get too hung up on F of G, because it could also be G of F. You know, you could reverse them. Or you could change the letters of the function and it could be like H of Q, you know, so don't get super hung up on what it's called. So for 11, these are our 2 functions. And here are the problems that we're going to do. So looking at A, you start with the inside function, and I usually circle it and then draw a little arrow. It's like the telephone game. Do you ever play the telephone game? Do you know what I'm talking about? Like someone whispers something to someone and then they whisper it to someone else and they whisper it to someone else and it gets passed along. Okay. And it keeps on getting changed. You know how like the sentence ends up real funny at the end. Anyway, you're going to do G of 4, and whatever you get, you're going to pass along to function F. All right. So here's G. We're going to plug in 4. You ready? 2 times 4. 8 plus 1, 9. So this is going to be F of 9. Ms. Cole, do we have to show that? All I'm going to say is if your final answer is wrong, I cannot give you any partial credit. And I usually make these worth 2 points, and you will get -2 with no partial credit. So I would say, yes, you do need to write it so that I can follow your thought process. All right, now we're going to do F of 9. So we're going to plug in 9 right here. 9 squared, 81 minus 7. Is that going to be 64? Oh, 74. I'm sorry, 74. All right, let's try it again. Which function do we start with for this one? Yep, f of -6, and I usually circle it. Start with the inside function, and then like the telephone game, it's going to get passed along to the outside function. So we're going to do f of -6, whatever we get, it'll get passed along. -6 squared. Good, positive 36 minus 7 be 29. So we're going to do g of 29. So plug 29 in for x for function g. 2 times 29. What I would do is I would double 30 and then just subtract 2. So if you double 29, 58 plus 1, 59. This is f of -2. That's fine, we can do that. You're going to do f of -2, and whatever you get, plug it back into function f. It'll turn out different. All right, -2 squared, 4 minus 7 is -3. So we're going to do f of -3. -3 squared would be 9, minus 7 is 2. So just be careful which function you're doing first. Number 12 is the exact same thing except with graphs. It's even easier because you actually don't even have to do any math. You just need to like point to the like place on the graph that you're looking at. You're doing the same thing though, and again, I always draw the arrows. G of -1, and whatever you get, you're going to pass it along like the telephone game to function f, right? So let's look at G. They're labeled here. The parabola is G. G of -1, that's this point right here. If you plug in -1, what do you get back out? 1. Do you guys see that there? -1, 1. You can even write down the point if you want to. All right, if you input -1, you get +1. So this is f of +1. And then you're going to go over to function f and find that point. It'll be 1 comma whatever. You're looking for the output. So if you input 1, what do you get? -2 is your final answer. Hey, Ms. Cole, I didn't quite get that. I'm about ready to do it again. You ready? Which function do we start with here? G. G of 0, whatever you get, you're going to pass it along. So what is G of 0? 0. 0, 0, because it's on the origin. So f of 0 would be right here, -1. There's kind of no work for these. You're just looking at the graph. And then last one, which function do we start with this time? All right, f of -3. So find f of -3, what does that give you? Good, that'll be 2. Pass it along, we're going to do g of 2, which would be right here. So g of 2 gives you 4. We're all cool so far. Do you remember that from last year? Sort of? Okay. Now here we're going to do this with actual variables, which is a little tougher because you're not dealing with like numbers, you're dealing with variables. We're going to find f of g and g of f. They're different. You have to actually work them out separately. All right. And so what you have to do is label them for me so I know which one's which. So first we're going to do f of g. It's like f got hungry and ate g. So you're going to take the entirety of function g, this whole thing, and plug it in over here. Don't draw that on your paper because we're going to have to do it the other way in a second, and I'm going to have to erase mine, and it's going to be annoying to erase it. Just go with it. I'm going to show you it on mine. I don't want your paper to get all messed up, right? So you're going to take this entire function, plug it in for x over here. So it'll be 2 and then x minus 7 squared minus 5. So when you see x minus 7 squared, that means you have to write it twice. So if you even want to skip this step and jump straight here, I'm fine with that. If you're like, oh, squared, I'm going to have to write it twice. If you want to skip that first step, I'm okay with that. And then the 2 is going to wait patiently. This is FOIL, first, outside, inside, last. So x times x, x squared. And then what are the outsides and insides going to give you? I'll give you a hint, it's negative. Good, minus 14x. And then -7 times -7, 49, perfect. And then minus 5. And then you're going to distribute the 2. So 2x squared minus 28x plus All right, to double 49, I would double 50 and then just subtract 2. So if you double 50, that's 100. Minus 2 would be 98. And then your last step, just 98 minus 5. And again, if you're comfortable just doing that in your head, you can skip that step. You'll have plus 93 at the end. All right, now I'm going to have to erase that. When we do g of f, it's not like the subtracting where you can just go and negate all these things. It's not going to work that way. For g of f, f is going to get plugged into g. So you're going to take this entire function and plug it in over here. So it's going to be this whole thing minus 7. So that one's a whole lot easier, right? It would just be 2x squared minus 12. Why was that one so much easier? Like we had a whole lot of work here, but we didn't here. Why was that? Because you had to square that thing. All right, so that made that like a whole lot more work. We're just going to practice that a bunch more times. That's it. All right, so for this one, f of g of x, which function gets plugged into which? Good, g gets plugged into f. And again, if you want to draw, like circle it and draw the arrow, like showing the telephone game, basically, like how it's getting passed along, this entire function is getting plugged in over here. So it'll be square root x plus 3 squared. And so what's going to happen there? Yeah, square root and squared cancel. And so you just get x plus 3. I'm going to stop drawing the arrows after this one because I keep on having to erase them. All right, so for g of f, and again, you do have to write that because they're different. So you have to label them. You have to know which one's which. So for this one, f gets plugged into g. So this gets plugged in over here. So it will be square root of x squared plus 3. Now, a big part of these problems is knowing when to keep going and when to stop. You have to just stop for this. There is nothing else you can do. You can't cancel the square root and the squared in this case because it's not an x squared, it's an x squared plus 3. And if you want to give it a hug to remind yourself, the other thing I also say is no cancellation without factorization. Like if you didn't factor it, you can't cancel. So just hands off, which is cool because it's no work, right? We love no work. No work is great. All right, f of g of x. Again, you do have to label them because you have to know which one's which. So that means all of g of x, this entire thing, is getting plugged in over here. So it will be square root of all of that minus 8. So is there anything that you can do to that? No, just stop. And if you want to put parentheses around that, like give it a hug to remind yourself, then you can. There's nothing to be done there. I would say that's the most common mistake with these is that people meddle with them when there's really nothing you can do. All right, and then g of f of x. Now f gets plugged into g. So this square root of x minus 8 is getting plugged in over here. So you'll have 1/3 square root of x minus 8 squared. Can we keep going for that one? Yes, that one you can. The squared and the square root cancel. And then you would distribute the 1/3 through there. So it would be 1/3 x minus 8/3. 1 times 8 is 8, and then it's just thirds. 1/3 times 8 is 8/3. Don't overcomplicate that. All right, hang in there. There's only a couple more. F of g of x. G gets plugged into f. So this x plus 6 gets plugged in over here. So it will be 1/x plus 6. Is there anything else you can do? No, just leave it alone. And then g of f of x. F gets plugged into G. So it would be 1 over X, that's getting plugged in right there, and then plus 6. Again, there's nothing you can do. Just please be careful with how you write those and don't be sloppy about it, because do you see the subtle distinction between them? And they do mean two different things. And if I can't tell which one you meant with your fraction bar, then I have to mark it wrong. So just be careful, but you're done. There's nothing else to do there. All right, and then last one of these, f of g of x. This square root, absolute value of x plus 3 is going to get plugged in over here. So it is 1 over absolute value of x plus 3 plus 2. Can you do anything else there, or do you just have to stop? Can I do the 3 plus 2 and get 5? No. This is, I would say, is the most commonly missed one. You cannot do anything with that. Please just do nothing. The part inside the absolute value, you could treat that like those are parentheses. You're not allowed to mess with that. Just leave it alone. Okay? Like do nothing to that. And then for g of f, it's going to be the same idea. You're not going to be able to simplify any of this down. F, this 1 over x plus 2 is going to get plugged in over here. So you'll have absolute value 1 over x plus 2 plus 3. Like the whole thing is inside of the absolute value. But again, there's nothing to be done there. So just do nothing. Like just leave them alone. When there's an absolute value, don't do anything. Let's go with that. Okay, just leave them alone. And then I always like these ones. We're going to break them apart so that this function is f of g of x. So what I'm asking you for is, basically I'm giving you the answer. What's the problem? Like what would the function f be and what would the function g be if this is f of g of x? So we want f to be the outside function and g to be the like guts of it, like the inside function. Any thoughts? You want to try and pull it apart. What'd you say? Good. This would be 1 over x. And what would be the stuff you're plugging into that? G is like the inside. 2x minus 9. Good. Perfect. It's just the outside function and the inside function. Let's try it again. We want f to be the outside and g to be the inside. G is like the guts of it. So what's your outside function? There we go. We're just not being confident. We're just timid about it. Square root of x. You're right. Confidence. And then the guts of it, like the inside part, 5x plus 7. Are you guys seeing that? Like if you plug this into that, you get, hey, you're all stopped listening to me.